So this question was asked in GATE 2016 Electronics and Communication Engineering paper, set 3, in which you have given a differential equation which is d2y by dx square plus 12 times dy by dx plus 36y equal to 0 with initial condition as y of 0 equal to 3 and dy by dx at x equal to 0 as minus 36. So you need to find out the solution of this differential equation, that is the y of x. The NPTEL reference for this question is Engineering Mathematics Part 1 by Professor Jitendra Kumar, IIT Kharagpur. You can find reference in the lecture number 56, which is Higher Order Linear Differential Equations. So the useful data for this question is, if you have given a differential equation in the form that a naught d2y by dx square plus a1 dy over dx plus a2y equal to some constant k, then its solution contains two terms. One is complementary function and one is particular integral. Now, if k equal to 0, that is the case of this problem, so y will contain only complementary function as the solution. So to finding the complementary function, what you need to do, that you need to put d equal to dy dx in this equation, and you will get equation as a naught d2y plus a1 d of y plus a2y equal to 0. You put d equal to m and you get characteristic equation or auxiliary equation. So when you put, then you will get a naught m square y plus a1 my plus a2y equal to 0. Then you solve this equation for m and you get the roots m as m1 and m2. Now, if m1 and m2 real and unequal, that is distinct roots, so the general solution of y of x can be given as y of x equal to c1 into e to the power m1 of x plus c2 into e to the power m2 of x. Now, if m1 and m2 are real and equal, then y of x is given by c1 e to the power m1 of x plus c2 of x into e to the power m1 of x. If m1 and m2 are complex conjugate and given as alpha plus minus beta I, then the general solution y of x is given as e to the power alpha x into c1 cos of beta x plus c2 sine of beta x. So these three are the useful data for this question. So in this question, you have given the differential equation, which is d2y by dx square plus 12 times dy by dx plus 36y is equal to 0. So when you put d2 equal to d2 by dx square, d square equal to d2 by dx square, and d as d by dx, and by replacing d to m, you get characteristic equation as m square plus 12m plus 36 is equal to 0. So when you solve this, when you calculate the roots of this quadratic equation, you get m equal to minus 12 plus minus 144 minus 144 over 2. Then you get m equal to minus 6 minus 6. I am using, if you have a quadratic equation ax square plus bx plus c equal to 0, and then you can find x as minus b plus minus b square minus 4ac over 2a. So you can find the roots of this quadratic equation by this formula. Now you get m equal to minus 6 and minus 6. So this is the case of equal roots. So you can write solution y of x as c1 e to the power minus 6x plus x times c2 e to the power minus 6x. Now, you have given at x equal to 0, at x equal to 0, your y of 0 as 3. So when you put x equal to 0 in this y of x, you get c1 equal to 3. Now, your y of x becomes 3 times e to the power minus 6x plus c2 times e to the power minus 6x into x. Now, the second initial condition you have given, that dy by dx at x equal to 0 is equal to minus 36. So when you differentiate this equation with respect to x, you get 3 into e to the power minus 6x into minus 6 plus c2 into x into e to the power minus 6x into minus 6 plus c2 into e to the power minus 6x. So basically I am using d of uv is given as d of u into v plus dv into u. So this is the formula I am using to differentiate the multiplication of two functions. Now this is your dy by dx. Now at x equal to 0, this value will be given by minus 36. So when you put x equal to 0, you get minus 18 plus c2 is equal to minus 36. So your c2 becomes minus 18. So we get c2 equal to minus 18. So when you put c2 equal to minus 18 in this y of x expression, you get y of x equal to 3 into e to the power minus 6x minus 18x into e to the power minus 6x. Or when you take e to the power minus 6x as common, then you get 3 minus 18x. So the correct answer for this question is option A.